Hello, good afternoon from Europe. Hello, everyone. I hope you can hear us and see us. Yes, so welcome to the second episode of this training series, Visualizing Data with Impact, organized by the data.europa Academy together with Alberto Cairo. We are very excited to get started this second session on designing with integrity, that it will be around 1 hour and a half plus a Q&A with Alberto Cairo where he will address your questions. So please write your questions in the chat and they will be addressed at the end of the session. For your information, since there were many questions about this yesterday, material is ready for you with the recording slides and additional material and resources from Alberto Cairo on the Data Europa Academy lesson, Visualizing with Impact, that we will share with you shortly. So all of this is together for you, together in this lesson for you. Yesterday, we were very thrilled to see all this interaction in the chat, especially conversations on how to get this community ongoing and how to connect with your peers on data visualization. So we are very happy to announce that the European Data Portal hosts a collaboration channel. That is one forum where you can connect with other people to share best practice, connect with your peers, and with the wider data community. So we created a specific channel for this training session, so you will be able to join and interact with this community. So as mentioned yesterday, it's a 3-day training course. Today is the second. It's very interactive, so I really suggest you to stay until the end, and we recommend you really to register for the third episode happening tomorrow to get the full picture. I'm not taking more time from Alberto. Thank you very much, Alberto, for being with us. We very much look forward to continuing this session today. Thank you.
Thank you so much, Imma. And to those of you who attended yesterday's webinar, welcome back. Welcome back to my home, to my little corner where I get all my books written and all my classes prepared. As I mentioned yesterday, I'm surrounded by my books, my board games, and many other things. And as yesterday is going to be a pleasure to share some time with you, this conversation among friends that I also mentioned in yesterday's webinar. To those of you, or for those of you who couldn't attend yesterday, you can obviously consult the recording of the first webinar. The second one is going to focus a little bit more on the specifics that I outlined yesterday. We are going to get right into some of the topics that we covered in the previous webinar. So this is the outline of the themes and topics that each webinar is going to cover. Today I'm going to talk a little bit about certain myths that surround visualization. I mentioned one yesterday already, the myth that visualization can be based on rules. And as I tried to explain yesterday, there are really not many rules when it comes to designing visualization. All that we can rely on is in developing some sort of like decision-making framework that can help us make good choices whenever we design a data chart or a map or a diagram. And today we're going to get a little bit deeper into that framework. I'm also going to talk a little bit about when and how charts may mislead and how we can do about that. And later on, again, as I have just mentioned, we're going to get a little bit deeper into this framework that I'm trying to outline with you, always with the understanding that this framework is my own framework, not the framework. Every designer has its own or their own way of doing things, right? Anyway, so let's get started with today's webinar. Let's begin by reminding you of a couple of things, or where we left it yesterday. So yesterday, if you remember, I mentioned that this decision-making framework should be based on weighing different factors or different elements, the data that we need to visualize, the audience that we are going to present our graphic to, the intent, the purpose, which is one of the key elements in this decision-making framework. Yesterday, for example, I mentioned Elsie Lee Robbins's research on educational methods, on lesson plans, essentially, that can be, or educational literature that can be applied to data visualization. Constraints and also outcomes, they're also worth considering whenever designing any graphic. And if you remember yesterday, I mentioned that every decision in visualization must be deliberate. And this is something that I'm going to be hammering a lot today. And by everything, I mean everything, from the baseline that you choose from your graph, to the scale for your graph, to the intervals in your scale, to the type of graphic that you choose, to the color that you choose. Everything should have a reason behind, right? And you should be able to explain that reason to yourself and to others, to justify that reason. And if you remember, I also mentioned that the process of designing a visualization, as it is not based on rules, is always subjective, right? It's just a designer making choices about how to better design this particular graphic, but it should never be arbitrary, right? That's something that, again, connects with this idea that for every choice that we make in a visualization, we should have a justified reason to make that particular choice. Also, you remember, I also mentioned that today we are going to be focusing more on this diagram, in which I sort of like list the many elements that we need to consider whenever we design a visualization, from the very structure of the visualization, what we call the scaffolding, the scales and legends and so on and so forth, up to the visual design and the style and the typography and the color that we use for that visualization. But before we return to that diagram, I'm going to take a slight detour to discuss these myths that I believe that we need to take with a grain of salt. It's not that these myths are completely false, but they need to be approached with care, and then certainly need to be taken with a grain of salt. Yesterday, I already mentioned the rules of visualization. That's a myth. There are no rules in visualization. All that we have is a series of heuristics, principles, inherited practices, and so on and so forth. But those cannot be equated with rules of visualization. But there are many other myths that I have encountered throughout my career, right? Such as, for example, the data should speak for itself. That's something that I have heard many, many times throughout my career. Just show me the data, just show me the graphic, let me figure it out, or let's present this data as it is to people, and so on and so forth. Just present the data, and that's it. The data should speak for itself. And my reaction to this is, yes, sure, the data will speak for itself if you know what the data is about and what the graphic is about. If you don't know what the data is about, the data will never speak for itself or for themselves, right? It needs to be explained, right? The data needs to be made a talk for you, or explain itself to you. A picture is worth 1,000 words. That's also a myth. It depends on whether you can understand that picture, right? And I'm going to show you a perfect example of what I mean by that. And so many others. Show, don't tell. I usually tell people, because some people tell me, sometimes, or just, again, show me the data, just show me the graphic, don't explain it to me. And I usually tell people, well, visualization is always about pairing words and visuals, right? There's a role to be played by, and this is something that we will cover tomorrow in the third webinar, a role to be played by words, the title, the intro, the subtitle, the captions, and so on and so forth, the little textual explainers that you can put in a graphic. That's an intrinsic part of any explanatory visualization. With those elements, without those textual elements, your graphic will not be as understandable as it should. Anyway, so let me show you my favorite example to explain to people why we should take all these myths with a grain of salt, particularly the data should speak for itself, or a picture is worth 1,000 words. Let me show you a picture that many people believe is worth 1,000 words, but in reality, it may not be worth the right words, so to speak. I get to see this graphic every year in the second half of the year in Miami. This is the type of map that the National Hurricane Center, which is one of the branches of the National Weather Service, produces every year when there is a hurricane or a tropical storm or tropical depression approaching from the Atlantic Ocean or from the Pacific Ocean to the continental United States. Well, actually, this is not the graphic that the NHC produces. Is a conversion, a transformation made by a TV station here in Miami, right? This is something that journalists do all the time in the United States. They pick up the graphic from the National Hurricane Center, which looks like that, right? And they transform it into something that is a little bit more polished, a little bit more colorful. Anyway, Everybody who sees this map for the first time believe that they know what they are looking at, but most people who read this graphic for the first time or for the second time or even for the 10th time misinterpret this graphic constantly. This is something that I observe repeatedly in the in Miami, to the point that at some point back in 2019, I even wrote an article for the New York Times explaining to people how to read that damn map. Just because, first of all, I misinterpreted myself when I saw it for the first time. And then through through a research group that I'm part of, we have conducted several focus groups and surveys, etc., showing what types of misinterpretations people have about that graphic. As I mentioned yesterday, by the way, this is for those of you who didn't attend yesterday's webinar. All these slides are going to be made available to you, all right? So don't be afraid of not being able to click on those links, right? The slides will be made available to you, so you will be able to read all these articles and resources that I'm mentioning today. In any case, that's the map. This is the type of map that the National Hurricane Center produces, right? We have the map. We have what is clearly the path of the storm, the path of the hurricane. In this case, it was Hurricane Dorian back in 2019. And then we have that area surrounding that path, right? That cone that we have there surrounding the path. Well, if you ask people, and I'm pretty sure that many of you will have this misinterpretation. If I ask you what it is that you're looking at, what is it that that area is representing, right? If nobody explains to you what you are looking at, it is very likely, this may not be the case, but it is quite likely that you will interpret this cone as an area under possible impact from the threats of the storm, right? So, and this is the how many people read this map up to this day. Even people who have lived here in South Florida and Miami for many, many years still misinterpret this map as, if I am inside of the cone, I am in danger. If I am outside of the cone, I may not be in danger. I may be fine. So, for example, if you live in Key West, I'm actually going to zoom in so you can see what I'm looking at, right? This is where I live. This is Miami's around here, right? And this is an island called Key West. So imagine, which is one of the main touristic locations here in the United States. It's a very fun place. So imagine that you see this map and that you're on a vacation on Key West, right? Should you prepare for the hurricane or not? Well, if you ask people, and we have done this through this research project, if you ask people, would you prepare for the storm or would you be worried about this hurricane? Many people will take a look at this map and say, well, I don't know whether I should be worried. I mean, if I take a look at the boundary of the cone and the distance between that boundary and Key West, that's around 150 miles, like 200 kilometers or something like that, right? So it's pretty far from the boundaries of the cone. That's a dangerous misinterpretation of this cone, by the way. Not only that, some people not only interpret this cone as the area under threat. Inside, I am in danger. Outside, I'm not in danger. Some people also interpret the cone, or better said, misinterpret the cone as a representation of the size of the hurricane. This is another misinterpretation that we have observed repeatedly through focus groups. Even if there is a little explanation on top of the graphic that says the cone contains the probable path of the storm center, but does not show the size of the storm. It says it explicitly, but still people tend to see the size of the storm. This is a great example to explain a phenomena that I like to repeat to designers all the time. What you design, to designers or to writers or to everybody, what you design usually is not what people see or what people perceive. There's usually a gap in between those two things. Well, I'm going to get into the details of that in just 1 minute. In any case, what is the cone representing, right? What is the cone truly representing? Well, the cone is usually called the cone of uncertainty, and that gives you a glimpse of why, of what the cone is actually representing. But before I get to the next step, I'm going to make an aside. Some people, when I present this example, they say, well, how is it possible? How is it possible that people misinterpret this cone that way, even if the cone is actually called the cone of uncertainty, right? So it's a representation of uncertainty. What type of uncertainty? We're going to get that in just 1 minute because it's more complicated than it seems. But why do they get to these misinterpretations? And I believe that the reason is that when people see this map for the first time, they apply to it for very good reasons the wrong mental scheme or the wrong mental model to read this graphic. Let me show you what I mean. One of the most common misunderstandings about visualization is what I call the unidirectional model of graphical communication. The unidirectional model of graphical communication goes this way. You are a designer, a very ethical designer, very professional designer, right? On the left-hand side, that's the designer. That's a friend of mine, by the way. Her name is CCY. She's a journalist here in the United States. I got formal permission to include her portrait as the designer, as the prototypical designer in this example. So CC is on the left-hand side, designing the graphic, applying the rules of visualization, the best principles, the best practices. She designs a graphic. She presents the graphic to a reader on the right-hand side, and the reader is also a friend of mine, Scott Klein, who is a data journalist, presents the graphic to Scott, and Scott takes a look at the graphic, and understanding magically happens simply because we are using the best rules of visualization and the best principles of visualization. Well, yesterday I told you, well, it's not as simple. It's not that simple, right? This model is actually quite simplistic, right? So how does understanding of graphics really happen? What is the relationship between the designer and the reader? When we design any visualization, right, we usually do it with a particular mental model in mind, right? This is the data. This is how to best present it. I'm going to use this type of graphic, these types of encodings, this type of a scale. That's your mental model of what the graphic, how the graphic should be created, and what the graphic is representing, right? So you have that model in mind of how to better present the graphic, and you design the graphic with that mental model in mind. In your mental model, that cone over there is a representation of uncertainty. Again, I'm going to explain what that means in just a minute because it is a little bit more complicated than it might seem. But your cone is representing uncertainty. That's the mental model. Represent uncertainty, I'm going to represent it under an area. But it may happen that your reader will come to your graphic with a completely different mental model in mind. For example, it is very typical in cartography that any area that is bounded with a line, it is that type of model is usually used to represent areas that for some reason are geographically different to other areas, right? This is the area of the United States where we grow crops, or this is the area of the United States that produces oil, right? So this is the area that produces oil, and outside of the boundaries of that is the area that doesn't produce coal or that doesn't produce crops. That's a completely different mental model. Your mental model is the cone is representing uncertainty, but your reader may come to your graphic having seen many other graphics in which a bounded area represents something geographically different, and then automatically apply the wrong mental model to reading your graphic. And that's where misunderstanding happens, when there's a mismatch between your mental model and the mental model of the reader, right? When there's a mismatch, when there's a clash, that's where misunderstandings happen. So what to do about this? Well, I'm going to get to that in just 1 minute. But before I get that, I'm going to explain to you what that cone is actually representing. In my third book, How Chats Lie, I created, and also in the article that I showed you before in the New York Times, I have an explanation of how to read this cone. And in order to be able to read this cone, we need to explain to people in plain language, not in a statistical language, but in plain language, what is it that this map is actually representing. And this is the way that I usually explain it to just regular people with no statistical background. I say, well, in order to create this graphic, the National Hurricane Center, first of all, creates a lot of forecasts, predictions, right? Predictions. That's a step number one in that diagram. Those predictions are predictions of where the center of the storm. This is incredibly important to understand in this graphic, right? Where the center of the storm may go, right? By varying certain conditions of the weather, air pressure, temperature of the water, the hurricane, the center of the hurricane may go here or here or here or here in order to create that sort of like spaghetti type of display. That's a step number one. Then on step number two, the experts at the National Weather Service and the National Hurricane Center try to guess, and it's a guess. This is a guess. It's an informed guess, okay? It's a guess that is informed by years of predicting where hurricanes may go, but they actually guess what is the most likely position, what they think is the most likely position of the storm center in the following 5 days. That's step number two, the little red dots, right? They think, or they say to themselves, we think that the storm is going to be here, then here, then here, then here. But remember, this is just the center of the storm. Then what is done in order to create this cone is to surround those dots, each one of them representing what they think is the most likely position of the storm center, with circles of increasing size. And that's the representation of the uncertainty. To create these, they take a look at 5 years of past data, of past error. In statistics, error doesn't mean necessarily a mistake. It simply means the distance between what you forecast and what actually happened, right? The delta between those two, that's the error, right? So they take a look at 5 years of collected data about error in forecasts, and that's essentially the size of the circle, right? And then they surround the circle with a line, and when the circles are erased, that's the resulting cone of uncertainty. The way that I explain this to people is to say, well, imagine that you're reading this graphic, how you should interpret it. Let me go back to that slide because I need to zoom in, right, in order to explain to you how I usually explain this to just people who don't have any sort of prior experience in statistics or anything. I said, imagine that the cone is a target and you're playing darts, right? And you're throwing darts to the target. And each one of the hits that you get on the target represents a possible position of the storm center, right? It is very likely that the storm center may be around here. So imagine the dots hitting the screen. Each one of them will represent a possible position of the storm center. But it is also likely that it could be here or here or here or here. And there is also a chance, because obviously this error representation doesn't encompass every possible position of the storm center, there is also a decent chance that the center of the storm may go outside the boundaries of the cone. It's a much lower chance, obviously, because again, this is a representation of the probability of where the storm may go or may be. But there's always a chance, right? Small, but not super small, that the storm center may be outside the boundaries of the cone of uncertainty. That's how you explain it to people who don't have any sort of expertise in numbers, forecasting, data science, and so on and so forth. But then we need to add something else. The cone only represents the position of the storm center. So if you are in Key West on vacation, should you prepare? Absolutely yes, because even if the storm ends up going through the most likely path, which is this one, you may still be affected by the storm because hurricanes are gigantic objects, aren't they? So you may still be affected by the effects, by the negative effects, by the impacts of that storm. Would people understand this map better if it were explained to them this way, in plain language, completely devoid of jargon, statistical jargon, which I love, but to explain things to people, it's better to use just plain language and natural analogies, like playing darts or something like that? I believe that the answer is yes. And we have some proof of that through several focus groups, that when you present the graphic, but you explain to people what it is that they are looking at, people grasp it, people get it. And then the next time that they see the graphic, they don't need the explanation anymore because they are able to read the graphic. This is why graphics, right? This is why show don't tell is such a dangerous myth, or why the data should speak for itself is a dangerous myth. The dangerous myth, in my opinion, or the myth that that graphics should be self-explanatory. Well, they can be if they are very simple, but if a graphic represents a very complex reality, such as this one, it requires some explanation in order for people to understand the grammar of the graphic and the meaning of that graphic. That explanation is absolutely crucial. But we could go beyond that. If we keep, actually, if you remember in the first slide of this explanation, I wrote all these considerations, meaning, audience, content, and so on and so forth, are interrelated, right? We could also think about what is it that people really need to know, right? This is also crucial when we create a data visualization. Is it crucial that people know exactly where the center of the storm may go? Well, sure, it's important, right? But it's not the most important thing, because the threats or the risks that you may be exposed to when a hurricane is approaching your area are not really related whether you are actually in the path of the storm. You may be far from the path of the storm, and you may still be heavily affected by the storm, because the most dangerous elements of a tropical storm and a hurricane is actually not the wind, it's the rain and the flooding. Those are the most important, the most risky elements, the most risky factors in a tropical storm. So lately, the National Hurricane Center and the National Weather Service they're still using this cone to inform the public, but they are pairing the cone with another type of graphic called the Hurricane Threats and Impacts, HTIs, which in my opinion are great progress in terms of informing the public, because they are much better adapted to what the public, to what the audience really needs to know in order to prepare themselves for the impacts of the storm. So this is why these myths can be so risky. It's not that they are not true. There's some truth to them, but when they need to be taken with a grain of salt. It is also a great example of this fact that charts can mislead even if they are well designed. There's nothing wrong with the cone of uncertainty. If you know how to read it, you know how to read it. It works perfectly well for you. But if you don't know how to read it, if it is not explained to you, right, somehow, if we don't add an explanation to it, or if the TV news person who is presented the graphic to you on TV doesn't explain to you what it is that they're looking at, the chart will lie to you. And I do quotation marks here around the word lie, right? My third book is titled How Charts Lie, but it's really not, it's a joke. The title is a joke, because the book is not really about how charts lie. It's about how charts may mislead us, or how we lie to ourselves with the charts that we see every day. So let me insist a little bit on this with another example of a chart that misled me the very first time that I saw it. This is, by the way, again, the different elements, the different factors that we need to consider when designing a graphic that I was mentioning before, right? The audience, the content, and so on and so forth. Anyway, the graphic. The graphic that I'm about to show you was designed by a former student of mine, Luis Melgar, who is also from Spain, like I am. He's from northern Spain also. He's from Asturias. Luis came to the University of Miami to study data visualization, infographics, and so on and so forth. And today, he is a graphics reporter at the Washington Post in Washington, D.C. In any case, Luis was a journalism master's student of mine for a couple of years, and at the end of his studies, he created a capstone project, right, like a thesis project. And his capstone project was a quite ambitious data visualization project about homelessness in Florida. A project focused mostly on how many students, young students in Florida, are homeless, right? They don't have a home, right? Homeless people. In any case, I remember that Luis was working on this project for quite a while. He collected a lot of data, talked to statisticians and experts and social scientists, and so on and so forth, collected all these numbers. And one day he came to my office to show me some of the charts that he had designed. And some of those charts really shocked me, right? Take a look at these two maps. These are called choropleth maps. I will refer to maps a little bit later, and I will also give you some readings about data maps. Choropleth maps are those types of maps that represent data through color, either color hue or color shade. In any case, if you read these graphics, you will see that one of them is representing the share of students per county in Florida who are homeless, and the other one is representing the number of students per county who are homeless. I took a look at these charts and said, well, this is a humanitarian catastrophe. It's like there are some counties in Florida, particularly northern Florida, where 20%, 1 out of 5 of students are homeless. That's crazy. And then if you go to Orlando, on the right-hand side, the darkest county in the middle of Florida, that's where Orlando is. That's what Disney is. And in that county, more than 6,000 students are homeless. I said, but how is this even possible? And I remember the conversation with Luis, because he told me, well, just wait a second, because I have not explained to you what the word homeless means, right? Just saying the word homeless and presenting a graphic about homelessness can be risky, because people may jump to conclusions too quickly. That's what happened to me, because the image that came to my mind when I saw this graphic was a person who lives on the streets or who lives under a bridge, right? And that's certainly a homeless person. And there are many homeless people in Florida, unfortunately, and all over the United States. And that's a homeless person for sure. But that is not the only type, the only person who may be captured by the data by being homeless, right? There are other people who may also be captured by the data, who are also homeless but don't live under a bridge. Because the definition of a homeless person that is used by the state of Florida to count how many homeless people there are in the state is people who don't have a permanent home. I don't remember exactly the details, but it goes something like this. If you take a student, a young student, who comes, let's say, from a family that where unfortunately the parents are separated, or one of the parents has died, and the surviving parent is poor, and they cannot maintain a single home all year round. Unfortunately, that is the case of many people in the United States. That student, along with his or her family, needs to change homes every X number of months, 3 months, let's say, every 3 months. The student is living with an uncle. Then 3 months later, that student is living with his mom or her mom in a hotel. Then the other 3 months, etc. That student always has a home, but he or she does, or they don't have a permanent home. And that the student may be captured by the data. It may be labeled, it may be classified, it may be counted as a homeless person by the state of Florida. Now, that doesn't mean that the graphics are wrong. It doesn't mean that the data is wrong. All that it means is that the data needs to be explained. The data doesn't speak for itself. It may be speaking for itself if it is presented to someone who already has this type of knowledge, the right mental model, right? The statistician or the social scientist who knows a lot about what data is being presented to them. They are able to fill in the gaps, to fill in the details that are missing in the graphic. But if the same graphic, the very same graphic, is presented to the general public, that needs to be explained. We need an explanation that says the state of Florida says that a homeless person is blah, 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 and explain that to people. Because otherwise, if we don't include that explanation, that textual explanation or verbal explanation, if the graphics are presented in a live presentation, people will jump to conclusions. People will naturally misinterpret the graphic that we are showing to them. Let me show you just another example. And this also comes from How Chats Live, from my third book. This is one of my favorites. It's a graphic that shows, and it's a graphic that we get to see all the time in the United States, the US murder rate. Now, if you were born in the 70s or the 80s, I was born in the 70s, you may remember that the 70s and the 80s in the United States, it was a quite violent decade. There were a lot of murders, a lot of violent crime. This is what this graphic is representing. The US murder rate per 100,000 people went up quite sharply during the 70s and the 80s. It came down during the 90s for different reasons. It came down quite significantly. Then it stayed more or less stable throughout the 2000s and the 2010s. And then once we get to the end of the 2010s, the murder rate started increasing again. This chart goes up to 2015. But in How Chats Live, if I remember well, I have an updated version that goes all the way to 2018 or something like that. And the line continues increasing, right, after 2015. It has plateaued ever since. In any case, what is wrong with this graphic? Well, there's nothing wrong with the graphic. The graphic is great. The graphic represents the best available data that we have about violent crime in the United States. But if it is not explained, if it is not put in context, it can really mislead you. Because You may describe this graphic, and I have heard this graphic described many times this way, as the United States is becoming a more dangerous country since 2015. This is what our president wants us to believe, right? President Trump. And that's actually not true. The United States is not becoming more violent, right? It is violent enough as it is, but it is not becoming more violent. Or at least it is not becoming more violent everywhere on average. And that is the problem with this. It's not a problem with this graphic, it's a problem with the misinterpretations of this graphic, because what this graphic is representing is a highly aggregated metric. The US murder rate per 100,000 people, that flattens our interpretation of the data, when in reality, the underlying distribution of murders in the United States is extremely skewed, right? People who work with crime statistics will tell you that most places in the United States, sure, there's more violence than in Europe in general. But, if we could plot every single, let's say every single place, every single city, every single town, something like that, imagine that those dots down there represent a place, right? Most places will be around the national rate or will be below the national rate. A few of them will be above the national rate, and so on and so forth. But what is that is leading to misinterpretations here, which we have extreme values, right? There's some places in the United States that are so violent, certain towns, certain neighborhoods, right? Outliers in the data, right? Where violent crime is so prevalent and so common that they sort of like skew the national rate, right? That doesn't mean that we should remove them from the graphic, obviously, but we need to explain them to people, right? I usually use this example to explain specifically to journalists how important it is to add context to data, because we journalists have this tendency to try to simplify things. My friend Nigel Holmes, I have a book by him somewhere down here. Nigel Holmes is a famous visualization designer. And he told me once that journalists and designers tend to believe that the role of a journalist is to simplify things. And he says that's not the role of a designer. The role of a designer is to clarify things, which is completely different. This graphic is a simplification, right? It's a simplification of a very complex reality. But is it a clarification? Well, it is a clarification if you know what you're looking at, if you're already aware of this fact, right? That we have extreme values in the distribution. If you're not aware of this fact, this graphic is a simplification, but it is not a clarification. On the other hand, it's obscuring the interpretation of the data for you. But if we add this context, either by plotting every single place if we can, but if we don't have access to the granular level of the data, we don't have data for every single place, what we can do is to present this graphic, but then explain this to people, because this is an intrinsic part, to an intrinsic element to interpret the data correctly. So most misinterpretations that I see from people making from graphics, not all of them, but many of them, are not because people try to actively lie with graphics, right? Or to lie to themselves with graphics. They are usually the result of a lack of context, a lack of detail like these, right? That obscures the data, right? They are more the product of little mistakes that we all can make whenever we design a graphic by not thinking carefully. For example, in cases like these, about the nature of the data that we are presenting to people. In this case, it will be, what is the right level of aggregation to represent the data at? Well, national level, sure, not bad, but we may want to go a little bit deeper and represent the data at the local level, for example, or at least explain to people how the local level may lead them to misinterpretations of what is being presented to them. Anyway, that leads us, or connects, or is related to all these talk that I'm giving to you throughout these webinars about this reasoning framework, this reasoning process. Whenever we design a graphic, all that I'm talking to you about is related to that first element in the blue text on the left-hand side, right? Considerations about the data, about the information that is being visualized. It influences everything else. The fact that we have outliers in our distribution should lead us to present the shape of the data, not just an average or a median or a national rate, but actually a more granular representation of the data. And now we are going to start navigating this diagram little by little and talk a little bit about each one of the elements of a visualization, what types of things that we need to pay attention to in order to design graphics like this. So let's begin with the scaffolding, right? The scaffolding is essentially those elements that support in a visualization the understanding of the data, right? They support the data itself, right? Meaning scales, legends, labels, the baseline of a graphic, right? Many decisions need to be made about these elements, and those decisions, again, need to be deliberate. They cannot be arbitrary. Let me show you an example. If you remember in the webinar yesterday, I showed you the hockey stick chart, which is a chart that shows the variation of average global temperatures in the world from the Middle Ages to today. This is another version of that chart, but it only shows you data from 1880 to 2010. And as you can see, the line looks very different, doesn't it? Here, the line representing the variation of average global temperatures in the past 150 years or something like that, it looks completely flat. There has been no variation, right? And actually, the publication that published this graphic originally on Twitter said, this is the only climate change chart you need to see, meaning, yeah, we should not be worrying that much about climate change and global warming. That's all, that's alarmism, right? That's completely, the line is completely flat, right? But if we pay attention to the graphic itself, you may notice that there is something weird with it, right? Take a look. Let me just zoom in. And let's take a look at the scale, right? It looks a little bit pixelated because this comes from Twitter. Take a look at that. This represents the variation of global temperatures in Fahrenheit degrees from 1880 to 2015. And the scale goes from 0, well, actually from -10, up to 110 Fahrenheit degrees. But the baseline is 0, the baseline that is highlighted over here. Now, one of the elements, if you remember, again, if we go back to this diagram, right, these considerations about the nature of the data that is being visualized. If we are to critique this graphic, I will begin by saying, well, I will begin by saying this scale is completely absurd. And it is absurd for many different reasons that are mainly related to the nature of the data. The first reason is that the Fahrenheit scale, like the Celsius scale, doesn't have a natural 0. There's not a natural 0. And therefore, putting the baseline at 0 is completely absurd. That's the first reason that scale, that scaffolding element, is completely wrong in this graphic. Choosing the baseline carefully for our graphics should be mainly based on our understanding, our contextual understanding of not what the data is, but what the data means, right? What the data means. And that leads me to my second critique of a graphic like this, which is that it is not only that the Fahrenheit scale doesn't have a 0 baseline, it is also because at no point, as far as I know, in the past X hundred thousands of years, the average temperature of the world has been 0. And at no point in the past 100,000 years has the average temperature of the world been 110 Fahrenheit degrees. Therefore, the baselines of this graphic and the upper bound of this graphic are absurd, completely absurd. We could go even that, applying our understanding of what the data means, right? Not what the data is, let's say mathematically speaking or geometrically speaking, right? But our understanding, contextual understanding, more humanistic understanding, so to speak, of what the data means. At what point, or within which threshold, right? Within which threshold of this data on the Y scale is human civilization even possible, right? Is it possible at an average temperature of 110? Probably not. We will all burn to death if that were the average temperature of the world. Is human civilization possible at 0 degrees Fahrenheit on average? That's the average, right? Obviously, it's not possible because the Earth will be an ice ball. So at what point or through at which threshold, at what scale, what point of the scale is human civilization possible as we know it today? Well, it is only possible over a narrow band around that line. Actually, some critics of this graphic, and these are examples that I also included in How Chats Lie, pointed out that, that narrow wide band that you have there in the middle, that's where human civilization is possible. If you go too much upwards on the scale, you will get 200 feet of sea level rise, which is something that we may want to avoid. And if we go, let's say, 5 or 10 degrees below that line, we will get another ice age, which we also may want to avoid. Now, up to this point, all that we are doing is critiquing the graphic. But critiquing a graphic is not enough. Yesterday, I presented myself as an advocate for constructive critique of graphics that we see every day. Right now, we're doing the critique. But when we do a critique, we should also be ready, I believe, to propose alternatives. So what could be a more reasonable scale for a graphic like this, right? And this is where the subjective portion of the discussion comes in. I would say that this is a more reasonable scale, something that approximates, that zooms in to the chart, right? Perhaps taking into account the upper bound where we believe, although that's a fuzzy boundary, of the boundaries of where human civilization is possible, right? The lower end and the upper end. But where we put the baseline and where we put the upper bound on the scale, that's highly debatable. It's something that is entirely subjective. All that I can tell you is that I believe, based on the reasons that I have been giving you, that zooming into the chart to the area where human civilization is possible is a more reasonable, wise scale. That's what I mean by a subjective but not arbitrary choice. It is a choice that is based on our understanding of what the data means, right? What the data is actually representing. And then we can have a discussion as to where to put the baseline. Well, maybe, I put the baseline at 56, but it could be, for example, we could choose at the baseline as the baseline for a graphic like this. We could agree on putting it at, let's say, the minimum average temperature in the past, since the beginning of human civilization. What was the estimate at the beginning of human civilization for temperature? Maybe that could be a good baseline for the graphic. And then the upper bound could be the highest average temperature of the world throughout human civilization, right? That will be a baseline and an upper bound that will take into account the nature of the data and a good understanding, an honest and truthful understanding of what the data means, right? The decisions that were made on the original graphic seem to me to be quite arbitrary, or perhaps they were chosen on purpose to mislead people, although I cannot attribute intent, okay? I cannot attribute intent to the original graphic. Now, scales are tricky things, as you're seeing, right? The decisions that we need to make, again, are very subjective, but they can be reasoned about, they can be argued about, they can be debated, right? Perhaps we will be able to reach a conclusion, right? Let me show you other tricky things related to scales. Take a look at this graphic. This comes from the European Union. It comes from a wonderful series of interactive data visualizations about representation in the European Parliament, the different parties. There's also the gender representation here, women, male, and then other or unspecified, right? This is the graphic that I would like to focus on. I really like it. I really like the interaction of this graphic. But when I read it, I noticed something weird. I took a look at this. I said, this looks oddly regular, right? Very, very regular. And then I read the intervals in the chart, and take a look at the intervals down there and notice that the intervals are not equal. Take a look, for example, the first data point corresponds to November of 1979, and then the second corresponds to March of 1982. That's a 3-year interval. But then the one that I am pointing out with the white arrow over there, that's just a few months interval. It goes from May of 1994 up to September of 1994. That's a much shorter interval, right? So that doesn't render this chart, I would say, wrong, right? The overall message of the chart is still correct. On average, if we could trace a straight line, like a trend line, in this chart, female representation in the European Parliament has gone upwards systematically, right? Systematically. However, the details of the chart are hurt, in my opinion, a little bit by the fact that intervals are not well represented in the chart itself, that the intervals are represented as equal when they are truly not equal. They probably correspond to elections, right? And elections don't happen sort of like at equal intervals in every single country, I would say, perhaps. Maybe that's the reason these intervals are not equal. But the fact is that they are not equal. When we make them equal, which is something that I try to do manually, I took the graphic, redrew the line, and then manually move the intervals myself to see what it would look like. The chart still shows us the overall trend. So the overall picture is still correct, right? It's still going upwards, as we can see. But the intervals, they don't look so regular as they did before, right? So again, this is the type of attention to detail that we need to put to our graphics. We need to reason about the scales this way. If my intervals are not equal or equally spaced, they should not be equally spaced in the representation of the data itself, because that will hurt a little bit the understanding of the data. And if we can make them look more truthful or closer to what they are in the data set, why wouldn't we do it? Let's try to do it in a non-equal spacing, right? Now, maps have their own sort of like principles when it comes to designing scales. This is an example of a choropleth map. This comes from Eurostat, a wonderfully designed map, a choropleth map representing non-US citizens who fled Ukraine throughout the war and who came to other countries in Europe, seeking temporary protection. As you can see, the colors are representing the ratio per 1,000 people. This is a rate, and then the numbers itself on every country, they are representing the number of people coming out from Ukraine to each one of these, to each one of the other countries that are represented on the map. It's a perfectly designed map, wonderfully designed map. It's really readable. But take a look at the scale, right? I'm not going to get deeper into map scales. I'm going to give you a reading resource for you to read, because that will be an entire class on its own. Take a look at the intervals. Don't you notice that the scale looks a little bit, let's say, text heavy, right? Take a look, read the scale, and you will notice that it says smaller than 2.5, 2.5 to 5, 5 to 10, 10 to 20, 20. Isn't that a little bit repetitive to keep repeating 10, 10, 20, 20, etc., etc.? Wouldn't the scale look a little bit cleaner if we remove a little bit of the redundancy on the scale? Not only that, notice that this scale is completely continuous. There are no breaks on this scale, right? It goes from 2.5 to 20 or more, and there are no breaks in between on these categories. In maps, each one of the colors that we choose to bin the data in, we call those the categories of the colors. There are no intervals in the categories. There are no breaks, right? It's a continuous scale. But then the representation in the scale is done through circles with little breaks in between them. So they look like this is categorical rather than continuous. In a graphic like this, and it may seem like my being picky with design, but if the scale is continuous on a map like this, why not making the scale look continuous, right? With no breaks in between. And we label just the breaks in between the intervals. Again, it may seem like a small change on a map, but it will better match the nature of the data. The nature of the data here is not categorical, and there are no breaks on the scale. It's a continuous scale. So why not representing the continuity of the data by creating a continuous scale for the map? In any case, as I said before, talking about map scales will take a very long time. So what I decided to do is to include in the slide deck and also in the extra readings that, as you know, I'm providing to you, an entire chapter from one of my books, from my second book, The Truthful Art. There's a whole chapter, chapter 10, dealing with data maps. This is like 45, 50 pages, something like that. It's a very long chapter in which I wrote almost everything I know about how to design data maps. And there's a long discussion about how to choose better scales, better scaffoldings for the maps that we design every day in our daily work. Let's keep navigating upwards a little bit in this scale. Notice that I'm looking either at one computer or the other. There's a reason. The reason for that is I'm working with two computers here. I need to remember what comes next. Oh, this is my favorite part. Let's talk about encodings. Now, if you remember yesterday, I introduced you to the grammar of graphics, right? We had this discussion about marks and visual channels. So a quick reminder, we talked about this yesterday, right? In data visualization, what we call the grammar of graphics is this interplay between the objects that we choose to represent the data. We call those marks, circles, squares, triangles, and so on and so forth. And then the attributes of those objects that we vary, right, in relationship to the data or in proportion to the data. And we call those the visual channels. For example, in a bar graph, the mark is rectangles, and then the visual channel is length or height, right, depending on whether the bar graph is vertical or horizontal, right? So marks and visual channels. Now, yesterday, there was a question during the Q&A related to, well, how do we choose, right? Are you going to talk a little bit about how to choose types of charts or how to choose types of visual channels? Meaning, when should I use position? When should I use angle? When should I use color? And as I mentioned yesterday, this it will be a very long discussion. It actually takes 2 or 3 weeks in my classes, but at least I'm going to give you a glimpse of how to make these types of choices, how to choose between different types of graphics and visual channels. And also I'm going to give you a few resources that are going to help you greatly in the future. And I'm also going to talk a little bit about the science of data visualization, the research behind some of the assertions that I'm making for you here today. Let's begin with a very simple example. This actually comes from one of the several workshops that I did years ago for the European Union, right? This was a lot of fun. All right, so this is a graphic that shows of all the migrants who arrived to Greece in 2016, what countries they came from, what proportion of these migrants coming from different countries arriving to Greece, what proportion of them came from different countries. As you can see, it's a pie chart. Well, it's a variation of a pie chart called a donut chart, right? Using the angles of the display is representing the percentages of people coming from different countries. I remember that at the time when I look at this graphic, I wondered, what is this graphic trying to show me? What is it that it's trying to represent? And I actually talked to if I remember well, with the designers of this chart, and I asked, what is it that you're trying to show me? Let me make a guess. I think that what you're trying to help me see in this graphic is that nearly half of these migrants came from Syria, and the other half came from other countries, meaning that you want to emphasize Syria. Maybe that is because this was at the peak of the Syrian civil war, if I remember well. And obviously, a lot of people were fleeing from Syria and coming to Europe. So it's essentially a graphic that is trying to tell a story, right? So to speak, half versus half, or nearly half versus nearly half. Well, it works quite well for that, doesn't it? I mean, you can clearly see that Syria is almost half, and the other countries are almost half as well. However, right, I would think about, if I had to improve this graphic slightly, if that were the message that I want to convey, right? If I want to convey half versus half here, I better emphasize that message. How would I do that? Well, maybe playing with a color, right? One color for Syria, because that's the segment that I want to emphasize, and a single color for all the other countries. We can still see the boundaries between the different segments of the pie chart, but what I want to emphasize in my story is Syria, because it's nearly half of people arriving to Greece as refugees or as migrants, half of them coming from Syria. Now, as long as this discussion is about how to choose graphics, is the pie chart the right choice here? I would say that in this case it is. It works really well, delivers the message really well, mainly because the segment that we want to emphasize is quite close to being a multiple of 45 degrees, right? It's almost half of the pie chart, right? It's almost 50%. And therefore, it's very easy to read. And the message of the chart is, of all the migrants, half came from Syria. Therefore, I would argue the pie chart is a good choice for a graphic like this. But what about if the intent of the graphic were different? What about if the intent, remember that one of the elements that I asked you to think about from this point on is purpose, intent. What do we want to communicate? The pie chart works if the intent is showing a total and half versus half. It works really well. But what about if the intent was different? What about if the intent with our graphic is to let people compare these countries to each other? Imagine that we didn't have all these numbers surrounding this chart, and I am asking you to compare these segments to each other. It's very likely that you will be able to see that Syria is half, right? It's also quite likely that you will see that Afghanistan is around 1/4. But beyond that, it becomes really hard to compare the segments to each other. If you try to compare Pakistan to Iraq, or Iraq to Palestine, or Iran to Afghanistan, it becomes quite hard to compare the segments to each other. Now, what will be a good chart that will allow us to compare these segments to each other a little bit better? Maybe a bar graph. In a bar graph, comparisons become much easier. Even if I don't show you all those numbers, or if I only show you Syria's number, 47%, your brain will immediately be able to see that Afghanistan is around 1/2 of Syria, Iraq is around 2/3 of Afghanistan, Pakistan is around 1/3 of Iraq. Your brain will be able to interpret that graphic much more quickly if the purpose is to compare, not to see parts of a whole. And now imagine that our purpose were different. Imagine that our purpose with a graphic like this, it is not the case here, okay? But let's imagine that we had data for tons of different countries, right? For all countries from which migrants arrive to Greece, right? And we have data for tons of countries. And there is some sort, again, it is not the case here, just for the sake of argument. Let's suppose that there is some sort of spatial pattern to the data. Maybe the closer a country is to Greece, the higher the percentage of people coming from that country to Greece as refugees or as migrants. That will be a geospatial pattern that may be worth displaying. Again, it is not the case here, but if that pattern existed, it may be worth displaying through a map, right? Just to show that a spatial association between proximity and percentage of migrants arriving to that country. This is one of the first examples that I usually show to my students to teach them how careful the decision of how to choose what chart to use to display our data should be, and how close the connection that between that decision and our intent. And it is also a way for me to teach them that there are no right or wrong answers in the abstract, right? There are no right or wrong graphics, good or bad graphics. Now, some theorists in visualization hate pie charts, right? The pie charts are evil, don't use pie charts. Well, a pie chart may be fine. Like these, that pie chart is perfectly fine, right? In my opinion, at least. But it may not be the right choice, depending on what we want to show, depending on what we want people to be able to do or to see with our graphics. Remember that yesterday I referred to my first book titled The Functional Art. Whenever we design a graphic, we need to think about what the function, what the purpose of that graphic is. Showing parts of a whole, I would say that the pie chart in this case works. Comparison, the bar graph is superior to the bar graph. Or showing geospatial patterns, maybe the map will be better, although here there's no geospatial pattern. It is also a way for me to warn you all about one of the main mistakes that I see beginners make in visualization, which is to work a little bit on autopilot, right? This is an experiment, an informal experiment that I have conducted throughout the years. If I give a group of beginners a data set in which the data adds up to 100%, and without telling them anything else, I ask them, please design a chart for me, many of them, or most of them, will come back to class having designed a pie chart, just because we tend to associate percentages with pie charts. On the other hand, if I give people a data set that contains a spatial variable, like country names or states or provinces, I would bet that a great number of them will come back to class having designed a map. I love maps, absolutely love maps. But as I mentioned yesterday, most of what I know about visualization, I learned because I learned about cartography. But maps may not be the right solution, as this example shows you. Sometimes the map is the right solution. Sometimes the pie chart is the right solution. Sometimes a table may be the right solution, as I explained yesterday, depending on what the intent is, depending on what the purpose is. So let me show you that couple of resources that I have for you from this point on to consult whenever making choices related to this type of thinking, this reasoning between about the interplay between purpose and types of graphics. The first resource that I have for you is called the Visual Vocabulary. This is a poster that was designed by the graphics department of the Financial Times, the business newspaper in the United Kingdom. It's a very large poster that you can easily find online. If you Google Visual Vocabulary Financial Times, it is freely available online. What it is essentially a chart choosing tool, right? Here you have a bunch of icons, each one of them representing one of the most common types of charts available in most software tools these days, Excel, Tableau, Power BI, and so on and so forth. And the types of charts are categorized according to the purpose that they are usually used to fulfill, right? And they use it this way at the Financial Times. Whenever they are discussing a story, what story are we writing about today? Oh, we are doing a story about, probably the conversations don't go like this, right? But probably some of them do. What type of story are we doing today? Well, we are doing a story about, the performance of this company in the stock market over time. Well, that is a change over time story. That's the middle column, the green one. So we have all those options there that we could explore to visualize our data, because those are the types of graphics, the line chart and so on and so forth, that are better suited to represent change over time. But what about if our story is different? What about if our story is about ranking and comparing companies in terms of how well they are performing in the stock market? Well, that will be a ranking story or a magnitude story. And perhaps we should explore the graphics that we have on those two columns, because those are the graphics that are better suited to represent comparisons or to enable comparisons. So I find myself admiring this poster quite a lot. I love the design of it. You can download it in high resolution from the internet. There is even an interactive version of this poster that you can easily find online. Is a great resource, great resource. Another one is the data visualization catalog, and there are many others. I'm just pointing out a couple of these resources. This website is exactly what it says. It's a catalog of data visualization types. This website essentially includes, again, icons that represent the most common types of charts in data visualization. And each one of these icons is a button that you can click on. And when you click on it, you will get a short article explaining how and when to use a bar graph or a box and whisker plot or a scatter plot or whatever. Every type of graphic that you can think of, it's probably represented in this website. So it's also a great resource. And another most recent resource, yesterday I mentioned that I love recommending books. Well, here comes another one. I actually have it behind me. Practical Charts over here. This is a very recent book by my friend Nick Desbaratz. It's truly an excellent book, extremely practical, as the title says. It is full of these type of decision-making diagrams. It's almost like a choose-your-own-adventure. The older among you in the audience know what I'm talking about, the choose-your-own-adventure books from the 80s, right? If you want these, go to page this and that, right? Anyway, so these diagrams in the book work like that, right? Based on what you want to represent, the book guides you to the right decision. Do you want to represent parts of a whole? Yes, go in this direction. How many categories you have? Well, I have less than 3. Well, maybe you want to choose a pie chart. Or I have more than 3. Well, maybe you need a different alternative. It's a really useful book to have in your library. I truly recommend it. It's really good. But now I would like to talk. Oh, well, by the way, before I forget, Better Data Visualizations by John Schwabish is also an excellent, very similar to Nick's book. It's also quite practical to make these type of choices. But talking about John's book also helps me come back to Tamara Munson's book. This is a book that I mentioned yesterday. It's one of the books that I love the most in the literature about data visualization, because it summarizes a lot of the research that has been conducted throughout the years about data visualization. So referring to it again, it's quite helpful for me to make an aside and talk to you a little bit about the science behind the assertions that I'm making. For example, I said before, right? If you want to compare, a bar graph is better, right? If you want to represent parts of a whole, the pie chart may work. How do I know that? Or better said, what has led me to that opinion? Well, there's some research behind that opinion. So let me talk a little bit about that research. That research actually has led to this other diagram here that I'm leaving here for you, right? It's a diagram that shows the different types of visual channels organized according to a hierarchy, okay? A hierarchy of expressiveness and a hierarchy of effectiveness. I will refer to these two terms later on. But before I get to that, let me talk a little bit about how this hierarchy that appears in Tamara Mansur's book was created. This is a hierarchy that most visualization designers are aware of. Let me switch now to a graphic design tool in order to illustrate to you and explain to you the research where this comes from, right? There were two statisticians back in the 80s, in the 1980s, called William Cleveland and Robert McGill. This tool, by the way, that I'm using is called Adobe Illustrator. It's a visual design tool that I mentioned yesterday. Robert McGill, not Gill, Robert McGill. And anyway, Robert McGill and William Cleveland back in the 1980s conducted some of the experiments that up to this date we consider foundational in the academic literature of data visualization. Cleveland and McGill, by the way, William Cleveland has a couple of wonderful books about data visualization. The first one is titled The Elements of Graphing Data, which in my opinion is foundational in the literature of visualization. But let's talk about the papers that they wrote back in the 80s. So Cleveland and McGill were interested in what we call in visualization the effectiveness, not the expressiveness. I will talk about expressiveness in just 1 minute. The effectiveness of visualization. Effectiveness in visualization is a technical term. Effectiveness in visualization means a accuracy of perception of the data being represented. How accurate the judgments you can make out of a visualization when you see data being represented in the visualization. That's what effectiveness means, right? So I'm going to write it here, effectiveness. So Cleveland and McGill were very aware, effectiveness. That data, when we represent it graphically, can be represented in many different ways. So they designed several experiments that went this way. They began with a bunch of numbers, a bunch of magnitudes. I'm going to make up these numbers, right? The experiments were actually more complex than these. But let's suppose that we have a very simple data set only containing two numbers, 20 and 40. Let's suppose that these are whatever you want, 20 million, 40 million, 20%, 40%, a couple of numbers there, 20 and 40. Well, we could represent these two numbers using different types of visual channels. For example, we could represent 20 and 40 using position, right? So we have a 0 baseline. I'm going to draw it here. 20 will be here. 40 will be more or less here. I'm going to eyeball it, 20 and 40, right? Based on this common 0 scale. As an extension of these, we could also represent these two numbers using height, as long as we have a 0 baseline, right? 20, if we represent it with a bar, will be here, and 40 will be here. It's actually, the dot should be a little bit higher than before. I was not very good at eyeballing the position, okay? So I'm going to just move it up, right? 20, 40, 20, 40. We could use other, visual encodings, right? Visual channels to represent this data. If you remember the diagram of visual channels that I showed you before, we could also represent these numbers using bubbles, for example. This is representing 20. Now, this is going to be a little bit more difficult to eyeball. So 40 will be something like this. I may be a little bit off in my estimate. 20, actually, the second bubble should be slightly smaller, I think. Something like that, 20 and 40. And we could represent them also using angle or using color shade. Color shade is another way to represent data in data visualization, like in the warming stripe graphics that we saw yesterday. We could represent, or in maps, for example, 20, we could represent it with 20% gray or 20% blue, and then 40 will be represented using 40% gray. 40% gray, another shade of gray. So wonderful. We have 1, 2, 3, 4 ways of representing the exact same numbers, 2040, 2040, 2040. Now, as you may be guessing, this is not what the experiment was about, right? The experiment consisted in asking participants to make guesses, right? They asked people, again, it was a little bit more complicated than this, but not far more complicated. They asked people, if this is 20, what is this? Right? I'm going to add a question mark here. If this is 20, how much is that? Let me close this. If this is 20, how much is this? And if this is 20, how much is that? And maybe not surprisingly to you, now that I'm explaining the experiments to you, people were very, very, very accurate at perceiving the actual magnitudes with these two visual channels. Position, height, measure over a common scale were the most effective ways to represent the data, but effective in this specific sense that I'm mentioning, specific and accuracy of perception. All right. This is more accurate than these in terms of perception, and this is more accurate than these in terms of perception, right? They are all equally, let's say, accurate in terms of representation, right? The height is proportional to the numbers. The area is proportional to the numbers. The colors are proportional to the numbers. So accuracy of representation is equally effective, so to speak. But accuracy of perception, that is not equal on the part of the reader. This is more accurate than this, and this is more accurate than that, meaning this is more effective than these, as this is more effective than that. Now, what lesson could we extract from that? Well, the lesson is that William Cleveland and Robert McGill ended up creating a scale of methods of magnitude representation, the one that you have on the left-hand side, according to effectiveness. You know, the further up we go on that scale, the more effective, in this technical sense of the word, the methods were, and the lower we get on the scale, the less accurate the perception of the data was. But in the literature of visualization, we also talk about of the notion of expressiveness, and this is another technical term in visualization. So what does expressive mean? And then I will return to effectiveness just for a second before wrapping up the class and then going to the Q&A. So what is expressiveness? Expressiveness in visualization refers to how well, how organically, how intuitively the way or the channels and the elements that we use to represent the data match the characteristics of the data. So let me show you an example, a specific example of what I mean. Another pie chart. This comes from a student in one of my seminars, a cancer researcher. As you can see, it's a pie chart that represents the percentage of hereditary cancer syndromes, all right? Familial, sporadic, and so on and so forth, the types of cancers, etc., where the cancer comes from. Now, a pie chart like this expresses, so to speak, a total on its parts. We naturally perceive it as, that's what expressiveness actually means. What the chart expresses indirectly or actually explicitly is conveying to you parts of a whole. And if what you want to express is that parts of a whole, the pie chart is the right solution to represent the graphic. But if you take a look at the data here, you may notice that there are intervals in the data, right? There are not specific data points or data estimates. There's an interval between 15 and 20%, 5 and 10, 70 and 80. So what about if what we want to express is not parts of a whole, but the range of values in each one of these categories, right? We could also represent the data this other way, which was an alternative design that I presented to this student months ago. Depending on what we want to express, either parts of a whole or ranges, the representation of our information, the representation of the data will naturally change, right? This is why expressiveness is so important. Line charts naturally express change over time. Bar graphs naturally or organically express comparisons, and so on and so forth. Let's go back for a second before we wrap up the class today to effectiveness. What lessons could we extract from, I would say, from William Cleveland's and Robert McGill experiments in the 80s, which have been replicated throughout the years, right? In order to come up with that scale that appears in Tamara's book and also in my own books. I have my own version of this scale of methods of encoding of magnitude attributes. What lessons can we extract? Well, I would say that when we want people to be able to accurately perceive the data, right, or perceive the data with a high level of accuracy, we should try to go up in the scale, right? So when we want people to be able to accurately compare things or see change over time very accurately or see the associations between different types of elements very accurately, we should rely on statistical graphs that are built on Cartesian coordinate systems like these ones, the bar graph, the lollipop graph, the dot plot, the scatter plot, the line graph. All of them are based on the same visual channels, right? Position, length and height over measure over common scales. These are the types of graphics that enable more accurate judgments based on the data. However, and this is something important, a very important caveat, right? Expressiveness in terms of, sorry, not expressiveness, effectiveness in the technical sense of accuracy of perception, sometimes is not all that matters to us, right? Sometimes what we want with a data visualization is not that a reader is able to compare every single data point to every single other data point, which is what you can do with graphics that use length, height, and position to represent the data. Sometimes what we want with a visualization is to display the overall picture of the data, the overall patterns and trends that may appear in the data. And that's where the visual channels on the second half, on the bottom half of this scale of visual channels may come in handy, because a visual channel can be effective in the broader sense of the word, right? Because sometimes high accuracy is not the point of a graphic. I'm going to just go back to an example that I showed you before, data maps, right? Data maps like these are maps that all of them represent, sorry, the results of presidential elections in the United States, a choropleth map, a proportional symbol map, or a cartogram. These are the technical terms to refer to each one of these charts. Again, you can read more in chapter 10 of The Truthful Art. All of them use visual channels that belong to the bottom of the scale: area, color hue, color shade, and so on and so forth, meaning that they are not very good at enabling people to compare things or to rank things or to see very accurate associations between the data. But that is not the point of this type of graphic, is it, right? The point of this type of graphics is to provide these big patterns in the data, right? If you know anything about the elections, the patterns in presidential elections in the United States, you know probably that Republican vote that is represented through the red on the maps tend to be quite dispersed all over the United States, tends to concentrate mostly in rural and sparsely populated areas, right? The areas in the middle of the country, right? That ocean of red in the middle of the country, that's, you know, a majority or a plurality of Republican vote. And then Democratic vote, votes for Democratic candidates in presidential elections tends to be more concentrated on coastal regions and also in big metropolitan areas. You can clearly see that on the second map. The point of these maps, or the purpose, the intent of these maps, is not that you are able to compare Miami to Los Angeles, Los Angeles to Chicago, Chicago to New York. That's not the point of those maps. If what we wanted people to do is to rank and compare the counties or the states according to vote, we should go up in the scale, right? We should use a bar graph or a table or something like that. But the intent, the purpose of these maps is completely different. The purpose of this map is to show us who won where at a very high level, and then to show us this big pattern that I have just explained. Republican vote tends to be more dispersed and more concentrated on rural areas. Democratic vote tends to be more concentrated in metropolitan areas and also on the coastal areas. It's a bigger pattern. It's a geospatial general pattern, and that's why these maps are so effective. There are many other types of graphics that use visual channels that belong to the bottom of the scale, right? So for example, this is called a tree map. A tree map doesn't look like a tree, right? But it is called a tree map because it represents nested hierarchies. This is a graphic that was designed originally by the New York Times, right? The tree map is essentially like a fancy pie chart. You have a whole in this case is of all the trucks, big cars, trucks that were sold in the United States. That's the overall square that you have there. What brands are selling more? So the first rectangle corresponds to Chrysler, the second one corresponds to Toyota, and then the General Motors is the big one on the left-hand side, right? So you see a total, the portions of that total, and then the sub-portion of that total, because you can see that each one of these big rectangles is further subdivided into the different models. So this is using area, first of all, to represent the data. And it's called a tree map, by the way, because you could envision this graphic as if it were the trunk of the tree, the total, branching out into branches, the different brands of cars, and then further subdivided into sub-branches, right? The different models. That's the reason why this type of graphic is called the tree map. But anyway, the encodings here, the visual channels, are area to represent the sales of each one of these trucks, and then color hue and color shade are also used in this particular graphic to represent increases or decreases of sales of each one of these models that we have here. The point of a graphic like this is not for you to be able to compare this model to that model, this model to that model. If what we want to do is that, we should go up in William Cleveland's and Robert McGill's scale and create a table with some sort of bar graph that ranks the models and allows us to compare them very accurately to each other. The point of this graphic is more to provide sort of like a bigger picture of the data, right? Big things, small things, higher things, lower things, but we don't care that much about how much higher or how much lower they are at an accurate level. It's more about the big patterns and the big picture of the data. Anyway, that's all for today. We will continue with this discussion tomorrow, in which I'm going to go a little bit deeper into visual design aspects of data visualization. I hope that it didn't bore you that much today. I know that it's a lot to swallow, a lot to digest, but I hope that I was understandable enough for you. Just as a reminder, episode 3 is going to be at the exact same time tomorrow, my morning, probably your afternoon. We will talk about visual design. And also, don't forget that there are some extra readings available to you, both through the data.europa's website and also through this link that will lead you directly to my personal Google Drive, where you can download all these readings and also the slide decks. For right now, the 2 first webinars, and tomorrow I will also add the slide deck for the 3rd webinar. And that's all for today, but we still have plenty of time for questions. So I'm going to stop sharing my screen. Stop sharing. So I can go back to the chat window. All right, let me go to the questions document. Let's see what questions you have posed. There's a question, are you a professor in a source of master's degree? Yeah, we have a master's degree in data science here at the University of Miami, and my class is mandatory to all data sciences students. That surprises them because, they come to the master's degree thinking that they are going to learn all about machine learning, artificial intelligence, statistics, and so on and so forth. And they do learn about that, but they also get thrown in the very first semester in a design class and a communication class. But fortunately, students tend to like the class quite a lot. My class is also part of the Masters in Journalism, Masters in Interactive Media. So yeah, I teach in several master's degree. There's a question about my courses, whether they are available online. Not my courses at the university, but if you want to learn more about visualization, I mentioned this yesterday. In January, I am going to launch this initiative, the Open Visualization Academy, which is a huge library of free learning resources about data visualization. Oh, there's a great question about circles. What about the confusion between the radius and the area of the circle? Yeah, that's a big one in data visualization. When we represent data using area, we should use area. We should not use the diameter of the circle or the circumference of the circle, because that will be misleading. In the chapter, by the way, about the chapter that I mentioned, chapter 10 of The Truthful Art, my second book, which I made available for you through the slide deck, there's a whole discussion about how to better design area-based maps, how to calculate the areas, and so on and so forth for data visualization. So yeah, that's a big one. Yeah. There's a question, often you don't know the patterns in the data until you visualize them, and only then is when the point that you want to communicate becomes clear. What is your starting point? That's such a great question. So that's a question that belongs, let's say, to the data understanding or the data exploration phase in the creation of any data visualization. Sometimes when I work with clients as an art director, the client or collaborators, right? The client or collaborator who wants me to help design a data visualization already has a clear idea in mind of what the patterns we're highlighting and what displaying are. We want to communicate this, and this. And when that is the case, my job is really easy because I just need to find a way to better display those stories, quotation mark in there. We will talk about stories tomorrow, insights or patterns in the data. So I just need to think how to better display them, how to better communicate them. But sometimes a client or collaborator comes to me and my own collaborators without a clear idea of what is worth communicating from the data. And therefore, that leads us to make a little bit of data exploration ourselves. I usually don't do it on my own because I'm not a statistician, I'm not a data scientist, I am just a designer who likes this stuff. I usually do all that in collaboration with experts, right? But I sort of like provide also my input to that process. So that comes before, obviously, the design. You need to find out what is worth communicating before you can communicate it, obviously. Let me see what else we have here. I'm going to look to my big screen here on the left-hand side. You mentioned that you closely study cartography before changing careers. Do you have any suggestions for standing cartography textbooks? Yes, I do. And you know me well already, and you know how much I love recommending books. There is one of the books that essentially changed the way that I think about visualization is titled Thematic I'm going to write it down in the chat window, okay? Thematic cartography. Sorry, just crossed my book by, slipped my mind. Thematic cartography and geo-visualization. Thematic cartography and geo-visualization by Terry Slocum. I just put the reference in the chat window. I highly recommend that book. It's a fantastic book. There is also Cartography by Ken Field. Two books actually. Has a second one coming out by Ken Field. That's a great also introduction to cartography. And I would also say How Maps Work. This has to do more with the visual perception aspect, visual perception and visual cognition aspects in map understanding. That's a classic book in the literature of cartography. And one more before I forget, by the way, because I didn't include it in the presentation, but it's one of my absolute favorites books in data visualization. This one, Information Visualization, Perception for Design, right? This is by Colin Ware, right? This is I believe that this is the third edition. There should be a fourth edition of this book. This is the best introduction to data visualization from the point of view of visual perception, okay? Visual perception and visual cognition. I know that I'm recommending a lot of books, but as I mentioned yesterday, if you are serious about learning data visualization, you need to build your own library. It doesn't require to buy a lot of books, but I would say that 5, 6, 10 books that are classics in the field. The last book is called Information Visualization, Perception for Design by Colin Ware, right? Information Visualization, Perception for Design. Let me see what else we have here. I'm not in a rush to leave, so we have plenty of time for Q&A. Taking into account the above, it can be said that both data and data visualizations are not neutral. They reflect a position, opinion, and point of view, and that requires judgment for both the viewer and the person working with data and visualizations. Thank you so much. You have summarized the main point of all my books, because that's essentially what I tried. One of the notions that I try to disabuse people of is that all this stuff is objective. It is not objective. The process can be objective, right? The process can be made objective if we apply the sort of like a systematic thinking in deciding what to show, how to show it, how to choose the scales. As I tried to show to you, that process can be made objective by expressing out loud and discussing the decisions that we make. But our values, our motivations, when we display or analyze or visualize data, those are never objective. They can be reasoned about, they can be justified, right? But there is always a point of view intrinsic in any message that we create, and in any data visualization that we create. Okay, let me go to the again to the questions document. There's also a question about generative AI. I addressed this yesterday, but I'm going to repeat it today. I am honestly, let's say I have tried several, I tried ChatGPT, Gemini, and other solutions to generate data graphics, and I was, I would say, utterly unimpressed by the results. So that may change. These, Gen AI may get better at designing data graphics, and probably it will. But for now, it's like I'm not particularly impressed by what I got from them. The way to incorporate Gen AI to a workflow, I believe, may come in more on the coding side of things, right? To generate code, for example, these tools can be extremely helpful if you know what you're doing, because that's the critical part of it. You need to have the knowledge required to verify whether the code, the analysis, etc., being generated by the tool is sound or not. But that is also true of any other tool. There's also a question: how do you go about what scales to use? Well, I sort of like discussed that a little bit throughout the webinar. As I said, every graphic is different. Every graphic. So the way that I go about choosing scales for my graphic is to try to understand, let's say, not the geometrical representation of the data. That is easy, right? Equal intervals and so on and so forth. It's more about having a more qualitative understanding of what the data means, the implications of the data, the gaps in the data. For example, you have a scale that has gaps, those gaps need to be shown on the scale. So every graphic is completely different, and therefore every scale for every graphic is also different, because the scale needs to be adapted somehow to the nature of the data. I was taught that 3D charts, especially 3D pie charts, are virtually always bad because they are misleading. Do you agree with this claim? And if not, what are some exceptions? If yes, are there other types of graphs that you would generally suggest to avoid? So I would say that I try to discourage people from using 3D charts, not only pie charts. I have examples in How Chats Lie of a 3D line graph that exaggerates the last data point because it is closer to us. So it's not just 3D, it also includes perspective. So 3D effects in static graphics can be dangerous, in my opinion. If your graphic is static, I would avoid in general three-dimensional effects, because they may distort your perception of the data. Now, interactive graphics, that may be a different story. For example, I have seen examples of 3D scatter plots. Rather than showing 2 dimensions or two variables, they show 3, right? X, Y, and Z with 3 scales. But then the graphic is rotatable. You can move around the graphic, so you can position in 2D to see the association between 2 variables. Then you can rotate it sideways to see the association between the 2 other variables. I found that quite intriguing. So that would be an interesting use of a 3D chart if you can navigate it in 3D space. But I would recommend to explore those types of solutions only if the graphic is interactive or animated. Okay. Great question. Why did you decide to design your layers and elements to think about diagram to be read from the bottom up? Because that is the way that I usually teach, right? But that doesn't mean that those elements are not related to each other. So I don't think sequentially. I explain them sequentially from the bottom up, but I don't think about them sequentially when I'm designing. I think about all of them in relationship to each other. That's an excellent question, because it connects to something that I have been thinking lately for my next book, which is that I will probably redesign that graphic as a network diagram rather than but it is useful sort of like a chapter, a table of contents type of thing, right? Because it's 1, 2, 3, 4, and so on and so forth. But it could be slightly misleading if I don't explain this actively, that it's just a chapter list from the bottom up. It's not necessarily the sequence of steps that you need to take. So fantastic question. There's also a question about tools. There was a question yesterday about tools. Also, what tools I use. I use all sorts of tools. Yesterday, I didn't mention, by the way, my old website. If you go to my old website, I'm going to actually post the link. I'm going to actually share my screen again, because this connects to the question yesterday. So just 1 second. I'm going to share my screen once again. Allow to share a screen. accept share screen. Okay, this is my old website here. The website is thefunctionalart.com. Okay, thefunctionalart.com, which is the title of my first book, thefunctionalart.com. That will take you to my old website and weblog. Okay, it has not been updated for the last couple of years because right now all my content will be published in the Open Visualization Academy and the newsletter of the Open Visualization Academy, which you can sign up for over here. Okay, that's where I'm writing these days. But my old website is still available. And if you go to the tutorial section over here, you can find a series of old tutorials that I recorded many years ago about some of the tools that I use in my own workflow. And this summarizes essentially my workflow for static graphics, which is essentially I can use a lot of different tools to generate charts. More and more, I find myself using R to generate charts, but I can also use Flourish, data.europa, Data Illustrator, row graphs. These are all freely available tools online. Quantum GIS to generate maps, QGIS. But then what I do is to export these graphics and I bring them into this tool that I have just shown to you, this one over here, Adobe Illustrator, and I do all my styling in this tool over here. I make my graphics look more polished, right? I do the layout, my layouts. Again, that's my workflow for static graphics, but not for interactive graphics. Interactive graphics is completely different. In interactive graphics, I may do a visual mock-up, what the graphic will look like, what the interface will look like, and so on and so forth, in a tool like Figma or Adobe Illustrator, etc., what the interface should look like. And then I collaborate with web developers, web programmers to transform that graphic into an interactive graphic using programming languages, for example, JavaScript. Or D3 and so on and so forth. But then again, I mean, those are the tools that I use, but that doesn't mean that those are the tools that you should use, because every tool is better suited for different purposes. So for example, if you work in business analytics, Power BI, Tableau, or Excel are excellent tools to ask. There's a question, do you use Shiny? I don't, because I'm a very basic R user. I use R and ggplot2. And a little bit more of the tidyverse, but no more. But I have friends who, if I need to design a Shiny dashboard, I usually hire someone to work with me, right? I'm not a very good programmer, so when it comes to designing more complex things, I just collaborate with experts in those areas. All right, let me see what other questions do we have in the question list over here. Oh, by the way, there's a mention about this workflow that I follow, right? Exporting the graphics from one tool and then styling them in Adobe Illustrator. There's a mention that sometimes that may alter the graphic or modify the graphic. That is absolutely true. It's very important to remember that my workflow, the workflow that I have just shown you in that diagram, only works, or I only use it, if my graphic doesn't need to be reproducible. If my graphic needs to be reproducible, then I may generate it entirely within a programming language like R. So I can provide the code, not only the graphic, but also the code behind the graphic for anybody else to reproduce. And when I alter a graphic, when I style a graphic in Adobe Illustrator or other program coming up from R and bringing it to the design tool, I am extremely careful not to modify scales, not to modify the aspects that actually are related to the integrity of the representation of the data. Okay. Let me see. When do you consider a data visualization successful? When it communicates its intended message to the intended audience. So usually you don't know whether a graphic is successful until you actually present it to people. And let me tell you, that's a humbling experience, because even after nearly 3 decades designing visualizations, the more I design, the more I read, and the more I observe, the less I feel I know about visualization. So testing, post-facto testing after graphics are created is an essential part of the process. We are doing, for example, in this project that I mentioned before related to hurricane mapping, This is a collaboration between researchers from the University of Miami, the National Weather Service. I am designing a lot of mock-ups, variations of the maps that I have shown you, but then we are bringing all those new designs to people, focus groups, experiments, etc., to see what they get, to see whether they actually interpret those maps more correctly or not. Okay. If I want to connect with you or engage, well, LinkedIn is, I am on LinkedIn quite a lot. I am on Blue Sky. I don't use Twitter anymore. Then the Open Visualization Academy's website, that's where you can find me. Let's see what else we have here. How many hours do you dedicate to the development of a static graphic? It greatly depends on the complexity of the graphic. Sometimes I find myself spending not only the complexity of the graphic, but also the complexity of the data behind it. Which again, when I want to interpret or understand data, I usually don't do it on my own because I'm not an expert on anything. I collaborate with people. So even a simple bar graph may require days to develop. Just because yesterday, for example, I showed a graphic that I designed to be presented in court during a law case, a legal case. It's a simple line chart. It's a very simple line chart showing the variation of a metric. Very, very simple. I can design that graphic, the graphic that I showed yesterday at the end of the presentation, that line graph shown in court. If I know exactly what I'm doing, I can design that graphic in half an hour, 30 minutes or something like that. But it took weeks to design. Why? Because we needed to understand the data. We needed to understand what is it that what it was going to be presented to the jury. What data points, what points in time were worth highlighting. We also needed to think about how the attorney, the lawyer, was going to present the narrative so I could put the labels in the right places. It took weeks to create that graphic. So the graphic itself was simple, but the narrative related to the graphic was quite complex, and the data, because the data also took quite a lot of time to process and understand. What is your take on some corporations focusing on action or AI rather than wasting time focusing on details? I mean, I have no take, or I would say I don't know, but I just think that details are important. And again, I would not say that I am skeptical about generative AI, but I see the hype related to generative AI. Let me make an aside. Do you remember big data? Do you remember how crazy people were about big data a decade ago? Big data, everything. Big data this, big data that, big data here, big data there. What is big data today? Well, it's part of our workflow. It's part of the conversation. It's still part of the conversation. But there was so much hype a decade ago about the very term big data. And I kept asking a decade ago, what is big data? And people said, well, data that is big. I said, okay, but how is that different from data? It's not data, right? So I keep asking about generative AI in the same way. So it's fine, right? I have used it to generate code in some, but how is that different from, what I can already, I mean, I can already write it myself. So these tools essentially help me speed up the process if I know what I'm doing. In some cases, I may use them to generate a chart. Again, if I know what I'm doing and if they get good enough to design charts, I may end up using these solutions to generate charts, but I still need to have that attention to detail myself, right? The human being needs to be part of the process, an intrinsic part of the process, right? Otherwise, you don't know what the tool is doing. And if you don't know what the tool is doing, you will not be able to assess what the quality of that. There's a question about breaking into data journalism. The job market is very tough and competitive. That is true. It is hard to get hired by a news organization these days because many news organizations are shrinking. They are laying people off. I would say, all right, two thoughts about that. First of all, if you want to pursue a career in data journalism within news organizations, there is not an easy path to that other than creating a name for yourself, meaning that you need to create your own portfolio, put it online, create your own personal stories based on data, obviously, publish them online, create your own publication or your own website in which you create your portfolio, you promote it actively, you become visible. And that may lead to essentially become so visible that you may end up getting land a job at a news organization. That's how many people in this field started, by taking data visualization and data journalism as a side career. They had their day jobs, And then on the side, on their spare time, they were creating their own personal projects, putting them online, promoting them, and eventually they were able to switch careers to something that is more related to data communication, etc. The other answer to that question is, besides doing that, you may want to look into opportunities not necessarily within the world of journalism, professional journalism. You may look into jobs or opportunities that may lead you to create data stories, but within the context, not necessarily of a news organization, but in a tech company, right? Google, for example, has this branch called Google Trends, and they produce things that we could consider data journalism. Microsoft used to have, I believe that they still have it, the Office of AI for Good. And what they do is essentially what I consider data journalism. They get big amounts of data, they create stories based on that. All right, so there may be opportunities in tech companies, there may be opportunities in science communication within universities, right? If you want to switch careers to data journalism, broader speaking, think much broader than the news industry, right? Journalism is not just the news industry. Journalism is a craft and a way to look into the world. And you can do journalism in other contexts other than the news industry. Are you okay with your programming coding skills, or is it something you would choose to improve? I would love to improve it, honestly, my coding skills, but where do I find the time? That's the thing, right? And do I really need to do it? That's always the question that I pose myself. Because data visualization, particularly when it comes to data visualizations that are more complex than a static line graph or a bar graph, etc., they are usually the product of the work of teams of people, right? So more and more I find myself, whenever I work on projects, and I may show a couple of projects tomorrow in the webinar tomorrow, more and more adopting the role of the art director or of the editor of the piece, right? I provide the overall direction. I coordinate a team of, let's say, a data scientist, a developer, a programmer, and so on and so forth, each one of them being experts in their own fields. Why should I step in what they already do when I can simply just collaborate with them? Now, that doesn't mean that it would not be beneficial for someone like me to get at least an elementary but working understanding of coding. I think that that's extremely beneficial, because then you know what the tool is capable of. You get a glimpse of what the tool may be capable of. You may be able to read the code and tweak the code here and there. But when it comes to doing complex things, it's the same thing with data analysis. I don't do data analysis myself. I'm not a statistician or a data scientist, as I have said repeatedly. So why should I sort of like have hubris to essentially take care of that portion of the job? I would just collaborate with an expert who can take care of that. Okay. Anyway, I think that is all for today. My mouth is a little bit dry, so I think that I'm going to drink a little bit of water. Again, thank you so much again for having me. I hope that you enjoyed the session today. I hope that has encouraged you to attend the webinar tomorrow. We will wrap up the series tomorrow. Again, have a nice evening, afternoon, or morning for all of you.